Okay, welcome back to the second session of our workshop. We are now starting the presentation by the group. And the first team is Andrew Speak, Federico Dini, Luca Surdi, and Ilaria Borselli. Who is coming? Yeah, please.
Andrew speaks.
Okay, good afternoon, everyone. So we we chose to study the storm Vaya, which happened 3 years ago. Quite a famous storm that destroyed a lot of forests in northern Italy. So it happened on October 29th, 2018. Wind strengths of up to 190 meters per second. I think that's right. Thousands of trees in the UNESCO heritage area of the Dolomites were blown over, including in this famous area of natural beauty, Lago di Carezza. I was there just last year, and it looks terrible. It looks like a bomb has been dropped, and it's going to take at least 100 years to recover. So we chose two periods of images, summer 2018 and summer 2019. We looked at choosing the period directly after the storm, but that was problematic due to high cloud cover in autumn, and also the trees had fallen, and so the signal that we were looking for, the green, would still be in the images. So we looked at the summer before and the summer after. Yeah. And so the idea is that there's a need to quantify the area of forest that was impacted. And from this, you can estimate the number of trees that fell over, and maps can be used to target timber removal and forest restoration actions. So the code we used was basically the graphical user interface that was shown in the tutorial in the morning. We changed the input cloud cover to 20% and changed the dates and drew a polygon over the area. And this loaded the Sentinel-2 image data, filtered it by cloud cover, constructed composites of the two periods, subtracted several bands, one from the other, and that showed how the images had changed between the two periods. And it used that green, yellow, red palette for the levels of change. And this is what we found. So the red points is where the large amounts of change were noticed between the two composites. And you can see this is how it looks on the map. So once we've got these areas, then we tried to calculate the area, but we didn't have time. But you can also calculate normalized difference vegetation index as well, using the infrared, near infrared and red bands. And so from those areas, and using, say, an average tree density of 600 trees per hectare, then you can estimate the number of trees that fell over, but we were unable to do that in this exercise today, unfortunately. And also you can superimpose a road network on top of that for the recovery process coordination. Okay, thank you. That was our project.
So, Andrew State?
Yes, so we gave you certificates.
With the others, Andrew, what the other? So,
Andrew. Then we have Sordi, Rossi.
No, io Dini.
Dini.
L'ultimo. Sicuro.
No. Dini e Borselli. Dini e Borselli.
Non è che tra i primi
Sì, forse sì.
Ora quali divido?
Rossi.
Grazie.
Io ho trovato.
Manca proprio Borselli.
Secondo me lei.
Forse non ci sei.
Il fatto che non hai dato la conferma è stato un problema.
Vabbè, magari te lo facciamo vedere.
Noi te lo facciamo.
Te lo facciamo avere in PDF.
Non c'è lei?
Tra l'altro qui c'è gente che non c'entra niente.
Magari.
Ciao, è stato un piacere.
Magari. Ok, so. Okay, we have the next group presenting is Niccolò Renzi, Piero Guatelli, and Jules Waihi. I don't know if anyone wants to come.
Sì? Perché non ha dato la conferma, forse, vero? Non avevi dato...
Ci sono anche della gente che invece non ha.
Devi cercare quello di
Guatelli.
Guatelli.
Sì, perfetto.
Jules.
No, questo è Bertoli, no? No, ok, su questo. Stai presentando. Is this one?
Yes, please.
Perfect.
The floor is yours.
Okay.
Good greetings, and I'm representing the group of Nicolo and Pietro, and our topic was the monitoring of the land change of a crop area in Emilia-Romagna. The case study is in the rural area of the Campagna, which is in Emilia-Romagna, with the coordinate of 44 degree and 10 minute north, 10 degree and 33 minute east. Our aim was to determine the land use change in the area of study during the summer autumn of 2018 using the GEE with the changing of detector application. This is our area of study. You can see Campagna is there. Before we run the program, this was the area, and on the first run for the first 20 days, we selected in the month of August. We took the first 20 days. There was a small change. We realized if you could compare between both images, using of course, the satellite and different layers. After 2 months, we realized that there was a huge change because this region is known to have different cereal production. So we said it could be caused by different harvest, and during this period, maybe the farmers could be preparing it for different other plantations, for example, like the wheat and everything. And the considerations was like the changing of the land in Campagna is supposedly an outcome of a given harvest and field works during this period because this region is known for its cereals like maize and wheat and other stuff. Thank you so much. We didn't go in depth, but thank you so much.
You can pass by there to take the certificates also. Next group is, I think, Giulia Megale and Elia De Innocenti and colleagues. So if you want to come here.
Come si chiama la vostra presentazione?
Kerala Analysis of c'è scritto nella prima slide.
Ah, ok. Andiamo, no, non è questo.
Questo è Gabriele.
Ah, presentazione, non è
No.
questa?
Sarà questa? No.
No,
Ah,
non
no.
è nessuna di queste quattro.
Ok, allora devo pescare dalla mail.
Questo è un tentativo di sabotaggio.
Chi ha mandato la mail?
Fabri Francesco.
Ah, questo.
Sì.
Perfetto. East. Thank you.
Hi, I'm Giulia Megale, and with my group, we did an analysis of 2018 Kerala floods using Google Earth engine. On August 2018, several floods affected the South Indian state of Kerala due to unusually high rainfall during the monsoon season. Almost 500 people died and about a million people were evacuated. And starting from the 8th August, in the first 48 hours of rainfall, the state received almost 310 millimeters of rain, which was about 16% more than usual rainfall. Our case of study was Vembanad Lake area. This is a NASA field scholar image that shows before and after the floods. This is the images that we extracted from the Copernicus Sentinel-1 image collection before, after the flood, and the flooded areas. This is the flood damage by land cover type, and we can see that the more affected areas were the red ones and the green ones that are croplands and grasslands. So this is our conclusions. The result of the simulation with Google Earth Engine are in agreement with the images released by NASA. The floods affected mostly croplands and grasslands, and around Vembanad Lake, urban areas have not been particularly affected by floods. Thank you.
Thank you, Giulia. Now, please pass by for. Now we have the presentation by Gabriele Bertoli. So
He's online.
yes, I need to give him the.
Yes. You can share your screen once we.
You should be able to share the screen, Gabriele. And now I'm.
Yes,
Okay, so we have to.
I am sharing it. I think it's loading.
Okay, I mean we should. We will try to make some kind of audio adjustment because we don't have.
Okay.
Can you speak?
Can you hear me?
Yes.
Perfectly.
Okay. So can I start?
Yes. Go ahead.
Okay, thank you. Hello, everyone. I did some analysis in an area near my place in the Magra River Valley. So we are we are between Liguria and Tuscany region, and this is the La Spezia Gulf. And I tried to work on the team 2, and I also so I decided to choose 3 different locations, and this in particular this is near some woods near Lerici, and this is the high level of NDVI. This is the medium level in the alluvial plain of the Magra River, and the low level is not really in the valley, but I had to go a bit far away on the Apuane Alps. This is a focus on the location just to have an idea on the kind of vegetation. This is a typical wood of the area. This medium location is a bit strange because, of course, it's a cultivated area, but I know that this particular field is abandoned, and so tried to also do this training example. And of course, here we are on the Aquane Alps, so the low location. I reported here some characteristics. Yes, here we have the coordinates of the points, but just to report them. The time window, I extended the time window to starting from 2018, just to see also the progress on different years. And I was able to set the cloudy pixel percentage set at 10 because I think probably for we are very close to the sea and maybe we have a lot of sunny days without clouds, and maybe this is the reason that was possible to use this parameter. And I will just go to the results. Of course, I think that they need some post-processing and some a bit more study on this outlier. Probably these are outliers. We can see that the 2020 was quite a good year for vegetation. We are in the high point, and we can see also that this summer was a bit more difficult for vegetation, and I have to say that we experienced some draft period, so it's probably coherent. And here we are in the medium region. Also here we have some outliers, but we also can distinguish that we in 2018, 19, and 20 we had good growth on let's say May in spring, and instead this year something changed because the peak of the growth was on the autumn. Yes, let's say on the last part of summer, and so this is a training. I tried to do this because it's a cultivated area, and probably the cultivation changed, and so this can also be an instrument to catch this. And about the low results, the low point results, we have of course some outliers also here, but the results are more stable, and there is very, very, very weak vegetation in this point. And that's all. Thank you.
Thank you very much.
Thank you very much.
Thank you.
Gabriele. Next group is Water Flood by Alessandro Berna, Lorenzo Ferrara, Vignai, and Sayed. Please.
Ma dobbiamo condividere.
Yeah, just an information by Fernando Mardi. You will receive the certificate by email. The online participants.
Thank you very much.
Si vede? Go, Alessandro. Go.
So, hello. So we did these analysis with the aim to use the functionalities of Google Earth Engine to detect and then do some work or some analysis of this flood event happened in the Chennai region in India in 2015. So this is a very impressive image of the event, showing the damage to all the infrastructure system and all the properties in the area of in this Chennai area around the city of Chennai. It happened in autumn winter of 2015, and we're counting something like approximately 500 fatalities. And obviously, an event like this is related. It can be related to the El Nino events that took place between 2014 and 2016. So just a little bit of overview of the area that you can see there. Well, you see the Palar River flowing from west to east in the Pacific Ocean, and it's obviously a very it's a low area. It's a low floodplain area. It's associated with some lagoon environment that you can see on the right of the picture, so at west. And it's an area that usually is also very with a very high hazard and risk of flood due to the monsoon events. typical of that region. So what we actually did was to choose a case study, so this 2015 flood, and to check the presence of it thanks to the scripts, to Google Earth Engine, and this is actually showing the date that we chose to detect the event. We had to play a little bit with the threshold of the difference obtained between the two images, the after images and the before images, because we obviously noted that there were differences in the outcome if we were choosing different threshold, and the same flood event shown here with this blue color was maybe less visible if we were choosing a high threshold. So after the selection of the event, we wanted to check to use other functionalities of Google Earth Engine, and we chose a different an NDVI MODIS database to select a temporal sequence of the NDVI production index of the area. Slide is just showing the script, and what we found out is that you can see in the center of the diagram that there is actually a very visible, high visible drop in this prop parameter exactly across the date of the flood. So it is a further confirmation of the occurring of the event, and also a scientific insight in what can be the consequences of an event like this. So speaking about purpose of doing something more, and we actually had some help from the tutor in finding this database that was a different one with respect to the Sentinel one that we were querying. What we see here on the right is actually the initial results that we got for the NDVI, and it's showing that we had no data for the Sentinel satellite between 2019. So what we were thinking is that would be like great for purposes of the future to write a complete code in which we can select the area, detect the event, and also try to automatically find the right database which had the data for the event that you are looking for. So that's basically all. Thanks.
Thanks a lot, very interesting. Please go and collect the certificates. The next.
I'm sorry. Can you please share the screen because we don't see your screen?
They don't see our
I
screen.
tried to tell you before, but it wasn't possible.
We didn't share the screen.
Oops.
No.
Sorry.
For the next one.
Okay. Please.
Prossimo, Allora. Voi siete... Ah, ancora non l'ho ancora scaricato. Ok. Eccola qua. Perfetto. Nascondo questo.
Okay. Hello everyone. With this presentation, I want to show you our case study that is about the. Can you hear me? Okay, thank you. In this presentation, I want to show you our case study that is about the Kien Giang river flood event in Vietnam on the 13th October of 2016. First of all, let me introduce the event. In October 2016, consecutive period of heavy rainfall have caused severe flooding in various provinces in central Vietnam. But on the 13th October, a severe flood event affected the area of Dong Oi City. And here are reported some infos about the event. In particular, I want to underline that more than 100,000 houses flooded and 39 houses collapsed. Very huge damages on infrastructure and also to crops and aquaculture, because this is a very important area for rice production. Going further in details, we have exploited the script about water detection on the Google Earth Engine platform to obtain the inundation area related to this event. We have considered as a period for the satellite images the period all the month of October 2016, and here you can see our result. But the most important thing is to look at the differences between the image in the first period of acquisition from the 1st October to the 13th of October, while in the second picture you can appreciate the inundated area with the differences with respect to the first period of acquisition. And here there is a detail on the city of Tianjin, where the inundation is very severe. While here you can appreciate this comparison between this work we have founded on the web. This is a research work of the Dartmouth Flood Observatory of Colorado. And you can see they obtained the inundation area in red on the left picture. And here you can compare it with our result. So, in our opinion, with my colleague Gens, we have obtained a quite reliable result, and probably we have to work on the threshold related to clouds and other parameters that are present in the script to obtain results that are more reliable and information that we can use in flood risk analysis. Thank you for the attention.
Thank you very much. You can go to collect the certificate. And then finally, we have the work by colleagues of the University of Florence, natural hazards, floods, and wildfire in Turkey, summer 2021. Paolo Samagnoni, Matteo Pampaloni, Marco Lompi, and
link a Google.
yeah.
Access.
Vabbè, allora apri il PDF.
Ok. E questa qua. No.
Expo,
Però la PPT non so se funziona con la PowerPoint. Non c'è il PDF.
Prova a scaricare.
Questo qua sarebbe.
Questo.
Questo è...
se no... Ah no, perché PowerPoint non ce l'ha installato.
Ce l'ha in pennina, se no.
Questo è PowerPoint, però non è
Ah.
lo stesso.
Sì. Si vede? Tanto si è fatto Google la preview.
Sì, ok. C'è un modo per farlo a schermo intero?
Google Slides.
Prova Open with Google Slides.
Vediamo se non fa casino.
Hanno fatto vedere Google Slides. Perfetto, vai.
Perfetto. Esatto. Fantastico.
So, hello everyone. I will take the floor for first, and I would like to present you our exercise of analysis of natural hazard in Turkey for the event of 2021. First, you can see the choreography of the case study. It's located in the Turkey region, prone to Cyprus, and you can see we analyzed 3 points of measurement that are prone to the wildfires that occurs in the region. As you can see in the center of the of the PowerPoint, you can see that the time period we analyze is between July and September of 2021. And we analyze only results from the Ibradi forest, that is one of the points we analyzed. We can see also the land cover change detection in Ibradi forest, and you can see the burned areas in the point of measurement, and then the Google Earth Engine source. We run the NDB analysis. You need to take attention to the lowest point, that is is well representative of the fire that occurs more or less in 30 July 2021. And now, please, Paolo.
And unfortunately, in the same summer 2021, many floods occurred in the north part of Turkey. We can see here some, I would say, impressive images of such floods. Occurred after intense rainstorms. So, in order to be able to detect which areas were flooded, we used the Google Earth Engine to evaluate the flooded areas. And we can see here an overview over the entire region of the flooded area. In particular, we zoomed in to the Buzurk. I hope the pronunciation is good. Where a huge flood destroyed part of the city. And here we played with some threshold parameter in order to highlight and increase the detail of the results in the valley. And that's it. Thanks for the attention.
Okay, thanks a lot. This was actually the final presentation, so I think we have very, very good works for the time available. And I think the slides that they show how you can do very wonderful elaboration with Google Earth Engine. Also, I mean, with 1 day of training. So suggestion is to continue if you are interested and to get in touch with us at the University of Florence, but also with Fernando and Antonio. We have a project together, and we hope you enjoyed this session, this workshop. I don't know if Fernando, do you want to say some final remarks or maybe Adriana and Elena?
I mean, just no. I already say a lot of things, and also the motivations and the expectations we had for this event were really reached. I really thank you for the participation. I know it's very challenging to do 1 day, start to finish with zero preliminary work, but you made it. So if you are interested in this kind of work, it's really part of our research and projects. So now you're students, but don't forget what we've done today in the near future. So with Riga, with Elena, with all the group you met today, from Fabio Castelli and the others, we do this kind of projects, training projects, this kind of events, because we do look for students and the young professional or young scientists willing to join us. So that's just my wish for the near future when you finish. Okay, so if you're interested, from thesis to post-thesis work, so be in touch with us. Okay, so grazie. Keep in touch. Thank you. Also for the online people.
Thank you very much.
Online people, thanks a lot, and we will try to send you the...
Thanks.
Grazie. Grazie ragazzi. Thanks a lot. So keep in touch. I hope you listen to me. Thank you, Riccardo, Didri, and all the others. I'm not looking at the names, but thank you so much for
Grazie a voi.
Grazie a voi.
participating. Abdullah, Bushana, Camilla, if you're still there, Giada,
Thank you for all of
Riccardo, Salvatore, Sergi, Victor. Thank you so much. So be in touch, okay, with us.
Thanks.
Thanks, bye bye.